Hello guys, this is Kumar from Icon Valley. Welcome again. In this session, we will discuss about what is Docker, Docker architecture, Docker setup. What is Docker? Docker is a computer program that performs operating system virtualization, also known as containerization. What is a container? It consists of binary and library files with appropriate image, and these are isolated from each other and bundle their own applications, tools, libraries, and configuration files, and they can communicate with each other through well-defined channels. That means Docker is based on virtualization, and virtualization is not a new concept, this is an old concept. But Docker brings it in a different way. How? We will discuss in the next slide. So basically in next slide, we'll discuss about the difference between a virtualization and what is the difference between a virtualization and Docker concept. We'll see the architecture. Guys, what is this logo? What is the story behind the logo? This is a representation of a whale, a fish, a mammals who swim on the ocean. So it defines that the whale is carrying a stock of containers on its way to deliver those to you. That means these blocks are the containers which which is on the well and which is used to the well swim on the ocean and he delivers to you to your doorstep smoothly. Such a big animal, such overlaid with the containers, but it swims smoothly. And that's exactly Docker does, because such a heavy application, such you don't have to install, you don't have to configure it. You just have to pull it. You just have to pull from the images from the Docker Hub, and which is smoothly you can operate the applications like this well. That's why they have given this symbol. So this is the architecture diagram between Hypervisor and Docker. In Hypervisor, what do you find? There is a guest OS which is installed on this host OS, and the applications are running on it. But these applications need the guest OS to run on it. But in Docker, you are missing this layer. This layer is no more there. So when there will be no guest OS, that means the hardware which is consumed here will be lesser in this Docker, because every OS take on hard disk, motherboard, RAM, CPU, everything. Now, in case of this Docker engine, or in case of Docker, it doesn't care about that. It doesn't consume, or it doesn't have the separate OS. So that's why it consumes less hardware. Okay, so that is the first advantage. So Docker not only share the hardware, but also it share the OS. Because here the host, the hypervisor, only share the hardware among the applications and guest OS. But here there is no guest OS, first of all, so you are saving the disk space. Second, you are not only sharing the hardware among these applications, but also share the host OS among these applications, and that is the PSP of Docker. Docker uses less hardware because it doesn't have that guest OS layer. What is the reason? How it is possible? I'll tell you in a very simple manner. Okay, so assume that one Windows machine you are installing, assume that you are installing an SQL here, okay, and in this machine Windows is running. Okay, let me write it here so it will be more clear. So assume that this is Windows and this is Linux. Okay, you put one uh, assume that a VLC media player. Okay, one software is there, right? You put the same software in Windows, you put the same software in Linux, the size will be different. Size differ. Why? If you understand this concept, then you can understand how Docker engine work. How without separate OS, without a dedicated OS for each application, how he is handling all the application in a single OS. See, I'll tell you. This Windows machine, which is installed here in this VLC media player, which is installed in Windows machine, it will consume more disk space. Why? Because this VLC media player are developed in Java and Linux platform. Yes, because maximum software developed in Linux, C, Java. Yes, because it is inherited from Linux only. So for every application, you need some binary and library files. VLC also require binary library files to run on an OS. And OS also need binary and library files to run an application. These are correlated. Now, when you will run the same VLC media player in a Windows machine, you require more binary and library files, and it create a folder there. You observe that when you install any software, it will create a folder in Windows. Why? Because that is not compatible with Windows. That is not developed on Windows platform. Yeah. So it create necessary binary files to install and to run. Yeah. But in case of Linux, it only require necessary binary files to, or it only require less binary and library files to run in the Linux machine because it is developed in Linux kernel. Okay. VLC media player binary library files are similar to the Linux binary and library files because they are equal. They are developed on that. So that's why when you install the same VLC media player in Linux, it will take a less size, but when you install in Windows, it will take more size. Yeah. Assume that one product is developed on Excel. One product is developed on Windows environment. The same product you install in Linux, it will consume more memory because the binary and library files are missing in the Linux system. Okay, so that concept, Docker engine uses that because Docker is hosted on Linux machine. Okay, it is hosted on Linux flavors. So as I told you, many maximum application are developed in Linux based kernel, right? So when you fetch this kind of, or when you run this kind of application in Docker engine, this image to run this application, whatever the image Docker will fetch the image from the cloud. And that cloud is called Docker Hub. Okay. So that cloud is called Docker Hub, and you are fetching the image from the Docker Hub. So that image contain necessary binary and library files, which is responsible to run on this Docker engine without a dedicated OS. It doesn't require OS because it has its own binary and library files to run on it. So that's why it consumes less disk size, like this VLC's media player is running on the Linux system. So Docker engine share the common binary and library files. So this contain this common binary library files. So this it share the common and binary and library files to each container. It doesn't have to install separate OS for OS like here. So Docker engine require a single Linux OS to run this application because it has its necessary images which you will pull from the Docker Hub, and that images contain necessary binary and library files to run on the Docker engine. So it doesn't require an extra guest OS to run. That's why it is hassle free. That's why without a guest OS you can run the Docker. That's why it is, appreciated by all the technology, or appreciated by all the company, and they want to implement Docker. Okay, uh, it will take less time because you just pull the image and it will work. You don't have to install here like separately. SQL install separately, Exchange separately, Java separately. For that you need you don't need separate OS. Suppose I want to install Java 5 and I want to install Java 8. Can you install Java and 5.8 in the same machine? No, but you can install Java 5, Java 8, Java 9, whatever you want to install, you can install in the same guest host OS because Docker engines separate these applications. It doesn't require a dedicated OS here. Got it? That's why Docker is very famous. By using a single hardware, by using the single OS, by using single hardware and a single OS, you can run multiple application and same application with different version also in the single OS, which is only possible in Docker, not in this hypervisor. Because hypervisor need different machine to run the different version. Because in the single machine you cannot install both the version, but in Docker you can install it because it is not related to your OS. It is related to your image, which is separate from each other. And that image, when you run that image in the Docker, that become a container. Okay. So now we are going to set up the Docker. So before set up the Docker, we will launch an instance. So go to AWS, okay, and there we will launch an instance, CentOS 7. So for that, you click on this launch instance, and we have to select a machine here. So what do? You have to go to AWS Marketplace and you have to write CentOS there. And in that CentOS, when you have to select this CentOS 7. Okay. So I selected that CentOS 7 here. Okay. And so this on this machine we will install Docker. Okay, so click on continue here, and we have to take T2 micro here. Okay, so this is the T2 micro, and let take free, and we will launch. Click on review lunch. And lunch. Obviously, you have to create the key here, and I selected the key. And so we have to generate a private key, and we will generate it, and we'll try to launch it. So we'll see whether it is going or not. So we'll go to the EC2 instance, and we can see it is running right now. So click on this, and it is running. Yeah. Oh, I give the name. So after doing that, I will take the putty session and I will launch it. Okay. I will open the putty, and here we will give the CentOS at the rate this IP address. So after taking putty, we can see the screen, the center screen. Now we are going to start installing Docker here. What I need to do, let me go to the Docker website where we can see the document, how to install those things. So this is the steps for installation on CentOS, and I'm going there, and these are the steps we have to follow. Okay, so first we'll go to this step. We have to set up the repository. So I'll follow this command. So I fire this command to install this utilities. Again, we'll go to that website. I'm just following it simple and install this. Right now, properly inserted there. We set up the repository. Then we are going to install the Docker. So just press the command here. Sudo yum install docker c, and these are the prerequisites. These are the essential packages to install Docker here. Okay. And it is installing. And the Docker is installed. Yeah. So we'll proceed further to check whether it is running or not. There are so many commands which is not required needed. It's saying if you need a specific version, the Docker engine list the available version and select and install. So if you need any version particularly, you can fire this command to list it out. From there, you have to use that version name here. But this is not required for us because we have installed the updated version. And so what we will do right now, we will just um, we will just check it whether it is running or not. Okay. So yeah, this is the command. We need to start it, and after starting, we'll verify this command whether it is coming hello world or not. So let me start the steps. Let me start the Docker, and here I'm going to, this is the command to start the Docker, sudo systemctl start Docker. It will start the Docker engine, and we will fire this command, and I fired it. So guys, after installing the Docker, I just start the Docker engine, and I just, for the testing purpose, I just run a command hello world, and it's created. Okay, and to see the image is created, and we to see the image, I just try to check it whether it is working or not. So I type Docker images, but it's showing some permission issue. So what is the issue here? The issue is we need to add the CentOS user to the Docker group so that CentOS have the privilege to fire all the Docker commands. So that we need to add it, the CentOS, to the Docker group, which is already created while you install Docker. So we'll do that. So as I said, guys, we have to fire this command sudo usermod -a g docker CentOS. That means I'm adding this user to the group Docker. Okay, and after that, I try to log in again because this will be implemented after login. Then if you type Docker images, and I can see Docker image. Okay, so I have to put it again. So it is saying is the Docker daemon is running. So let me check what is happening here. So guys, basically what I did here, I Docker images. I tried to check it. What happened? Uh, the Docker engine was not running. That's why it is showing is the daemon is running or not. So I restart the you start the Docker engine, and I can see that images hello world. Okay, so hence it is done, and our Docker is installed. If I check the version here, I'm checking the version. Yes, it is showing Docker 19. Okay, so this is the way we can install our uh, Docker machine, and we will proceed further on this by using some commands. Coming classes, we will discuss about Docker commands, Docker files, and port binding in details. For supporters, subscribe the channel so that we can upload more videos for you guys. Thank you. For complete videos and training, visit www.aconvalley.com